Hi, welcome. This is the first lecture for for critical thinking, and what we're going to start is kind of the idea of reasoning, of logic, of how you build an argument. Now, I know you look at me and say, "Well, that's not math, because math has something to do with numbers." Well, I would argue that it doesn't. The numbers are just kind of a mode by which we express it. But what math really is how do you properly reason and come to a conclusion. And there's two methods of reasoning. The first one is called inductive, and the second one is deductive. So we're going to try to investigate those two methods in this lecture. Okay, so our objectives are really pretty simple. Understand and see how to use inductive reasoning, where you start with a bunch of examples and end up with a rule, and then deductive reasoning, where you start with a rule and end up with examples. So basically, they're kind of the reverse direction. Inductive starts with examples and ends up with a rule. Deduction starts with a rule and ends up with examples. So let's see what we can find. Inductive reasoning is the process of arriving at a general conclusion based on observations. You look and see what's going on, and from it you predict what should happen going forward. Now, oftentimes we come up with what we call a hypothesis, sometimes called a conjecture. And it's just basically our guess as to what's going on. And understand that that may be true and it may also be false. That's okay. Now, the way you prove that it is false is you find something that counteracts it, a counterexample, something that shows that what we proposed, in fact, didn't happen. So let's look at a strong inductive argument. We take a random sample of a lot of freshmen at a four-year college. Now, granted, that's an awful lot of freshmen. 25% said they came to class without completing readings or assignments. Boo, you should do your assignments, at least in this class. But understand, we're going to do it a little different than some classes. We can conclude that there's a 95% probability that between 24% and 25% of all college freshmen frequently come to class unprepared. Okay, the method we're looking at is what's called a random sampler. We're going to talk about that when we get to statistics. But basically what it means is that everybody in the group has a fair chance of being chosen. And we can make predictions based on this random sample. So we sampled 380,000 freshmen, and we found that 25% said, I come to class without doing the work I'm supposed to be doing before I come to class. Okay, here's a nice weak argument. Men have difficulty expressing their feelings. Neither my dad nor my boyfriend ever cried in front of me. You've heard people say that. Hopefully it's females who say that. But either way, neither my dad nor my boyfriend ever cried in front of me. Okay, why is this weak? Well, your dad and your boyfriend are two people. So a lot more people out there than just two. You need to have more observations, more samples. The sample is just not random, because let's face it, your dad and your boyfriend, well, what I found out was that my daughter's boyfriends were a lot like me. And that happens a lot. So the sample is just too small, and it's not very random. It's the person that the young lady, let's assume young lady, could be a young man, chose to have as a dad, chose to have as a boyfriend, and did the boyfriend model their dad? Well, chances are they did. So let's try inductive reasoning. Let's look at this one. 3, 12, 21, 30, 39. Now, what's the number that comes next? Let's look at this. 12 minus 3 is 9. 21 minus 12 is 9. 30 minus 21 is 9. 39 minus 30 is 9. So 39, the next number is going to be whatever 9 plus 39 is. Well, that would be 48, right? So the next number in the pattern should be 48. Since the numbers are increasing relatively slowly, we just try addition. The common difference is 9, so this number is 48. Now try this one. Let's see. 3 to 12 is 9, but 12 to 48 is 36. Doesn't have a common difference. 48 to 192, well, that's certainly not 9. That's a lot more than that. And 192 to 468, that's a bunch. That's like 500. So that's not a common difference. But let's look at this. What's 12 divided by 3? That's 4, right? 48 divided by 12? That's 4. You may have to get your calculator. Well, 192 divided by 48? That's 4. 768 divided by 192? That's 4. So what's going to be the next number? Well, it's going to be whatever 768 times 4 is. So the numbers are increasing rather quickly. Try multiplication. The common ratio between the two is 4. So the next number is 4 times 768, that last number. So it'd be 3072. Okay, do you see how this is inductive reasoning? Do we know for sure that that's the right answer? No, we don't, but it fits the pattern. It's inductively reasoned. And sometimes you'll do an inductive reasoning and you'll come up with the wrong answer. And that's okay. Sometimes you see different patterns in here than let's look at this one. Can you look at this and tell me what you see? Okay. Is this a white object on a black background? If that's the case, you see a goblet. On the other hand, is this a black objects on a white background? In which case you see a face and another face. And they say they're looking at each other, but it seems to me that they're getting ready to kiss, okay? I'm going to be real open with you. So it looks to me like you can look at this and see two different things. So when you use inductive reasoning, sometimes there's two results or more. And sometimes you just got to pick out which one makes most sense for you. So let's try this one. 2, 4, what's the next number? Well, if you look at this, let's see. 4 minus 2 is 2, so the next number should be 6, right? Because, well, we're just adding 2 every time. Well, wait a minute. 2 to the first power is 2. 2 to the second power is 4. So this is 2 times 1, that's 2 times 2. This is going to be 2 times 3. And, oh, wait a minute, maybe it's 2 to the third power. 2 to the first, 2 to the second, 2 to the third. Well, then it would be 8. Do I have enough information to tell if the right next number is 6 or 8? No. We didn't get enough information in here. So we're going to have to get a third number before it makes sense, so we can find one solution. So maybe we look at this and say, if the next number becomes a 6, then the number after that's 8, and then 10, and then 12. It just keeps adding 2 every time. On the other hand, if this says 2, 4, and the next number is 8, then it's doubling each time. So the next number is 16, number after that's 32, number after that's 64. So you see, sometimes you need a little more information to come up with a single definitive solution than you're given. Okay, here's an interesting one. What number comes next? Okay, take a good look at it. I want to point out one thing. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. Oh, so what's the next number? 13 plus 21 is 34. The pattern is formed by adding the previous two numbers to get the next number. Make sense? So the next number is 34. Okay, let's try this one. Find the next figure in this visual sequence. Okay. Do you see a pattern? Well, there's one real simple pattern. The first one I looked at was, here's a 1, and there's a 1 up there. So it goes from the right-hand side to the top. The 2 goes from the bottom to the right-hand side. The 3 goes from the left-hand side to the bottom. And so the 3 looks like it's moving around. So it goes to the bottom. That would mean it would be going over here. It would be going up there. The 1 would go to the top, then to the side, then to the bottom. Then you go back to the top. And the 2 would go from the bottom to the side, to the top, to the other side. So he would end up on the bottom. But wait a minute. This one's a circle, right? This one's a square. That one's a circle. That one's a square. So what's the next one? Circle, square, circle, square. It could be a circle. So how would we draw the next picture? Okay, the next one's going to be a circle, right? but it also is going to have those 3 dots moving around in a counterclockwise rotation. So the next one's going to be a circle, but the 1 moves to the right, the 2 moves down, the 3 moves to the left, and the open spot ends up on top. So we're basically, this thing's rotating around. That's inductive reasoning. Inductive reasoning is really defensible as long as you get enough samples. If you don't get enough samples, it's sometimes going to be a problem. Deductive reasoning is the opposite. It says, I have a general rule. We sometimes in mathematics call it a theorem. And from that general rule, we can predict what's going to happen next. Okay, so here you go. One player to another in a Scrabble game. You have to remove those 5 letters because you can't use Texas as a word. The general statement, all proper names are not allowed in Scrabble. Texas is a proper name, therefore Texas is not allowed in Scrabble. Now, I don't know if you play Scrabble, but that's right, you can't put names in there. Let's look at this one. Select a number, 4, 7, 11. Now, you've played this game before. They tell you, pick a number. And you pick a number, and they say, okay, now multiply the number by 6. You did it by 6. Add 8 to the product, 32. Divide that by 2, you get 16. Subtract 4 from the answer, it gives you 12. Now, when you're doing a puzzle like this, oftentimes they say, when you get to the end, they say, okay, the number you predicted, or you ended up with is whatever it is. Because they set these rules up specifically to make sure that that happens. But see, in this case, this is deductive reasoning. Do you see a pattern? Multiply by 4, or multiply by 6, add 8 to the product, divide it by 2, and add 4. So that's going to be multiply by 6, add 8, divide by 2, subtract 4. Okay, so it's going to be take the number, multiply it by 6, that's 6 times the number, add 8 to it, that's 6 times the number plus 8. Now divide that by 2, that's 6 times the number plus 8, divided by 2, and we can simplify it down to 3n plus 4. You guys know that one. Now subtract 4 from the quotient. So let's see, 3n plus 4 minus 4 equals 3n. Do you agree with this inductive hypothesis? Did this do what we predicted? Well, if you go back and look at it, yeah, that's exactly what it was doing. Okay, so that gives you an introduction to both inductive and deductive reasoning. That's where we're going to be looking at right off the bat. This is how we have to start to think mathematically. So you guys, review this, start working on that first homework assignment, and we will talk about it when we get back together. Thanks, bye.